Hi, in this video, we are going to learn about different stages of a data model. But first, what is a data model? A data model is simply a diagram that displays a set of tables and the relationship between them. We can understand a lot more by looking at a data model diagram than by looking at a list of tables. This helps us in understanding the purpose of the table as well as their dependency. A data model is applicable to any software development that involves creation of database objects to store and manipulate data. Now, this includes transactional systems as well as data warehouse systems. When a data model is being designed, we progress through three main stages. They are conceptual data model, logical, and physical data model in this order. Now, let's look at the first stage, which is a conceptual data model. A conceptual data model is just a set of square shapes connected by a line. The square shape represents an entity and the line represents a relationship between the entities. A conceptual data model can be easily drawn on a whiteboard or a piece of paper. It need not be a digital document. This makes it easy and quick to change and can be rapidly updated. So, what are some of the attributes of a conceptual data model? First, it is highly abstract. When we say abstract, we refer to the fact that we do not have too much details, right? It is at a very high level. Hence, we call it highly abstract. It is easily understood. So whether the user is a technical or a non-technical person, it's easy for anyone to understand what this model is about. So as you can look at this diagram, it's easy to say that there are four main entities: time, product, sales, and store. And all of the three entities, which is time, product, and store, have a direct relationship with the sales entity, right? So that way there is a lot of information that can be easily obtained by looking at the conceptual data model. And since it is not a digital document, it can be easily enhanced. And the thing to notice here is only the entities are visible. There is something else called as attributes. Those are not visible, but we'll be talking about it in just a bit. And even the relationships are quite abstract, meaning we just know that the product is connected to sales, but what is the column on which the relationship is established? That is not clear yet. So this is a way of hiding the complexity at the very initial stages. And since a conceptual model can be written on a piece of paper or a whiteboard, you really do not need a software tool to create a conceptual data model. That makes it a whole lot easier. Once the conceptual data model is finalized, we can elaborate it into a logical data model. So let's look at a logical data model. So logical data model expands the conceptual data model by adding more detail to it. And what are those details? So first you'll notice is the presence of attributes. Earlier, what used to be a simple square shape now has a list of attributes. These attributes are further identified as key attributes and non-key attributes. So key attributes are attributes that define the uniqueness of that entity, such as in the time entity, it's the date. That's a key attribute. Similarly, we have product ID for product and store ID for store, right? So in the logical data model, you draw a line within each entity. All the attributes mentioned or displayed above the line form the key attribute, and all the other attributes below the line are called non-key attributes, meaning they do not help in uniquely identifying a record. An example is the category in the product entity. So category is something that could repeat for a number of records. Hence, it's a non-key attribute, and that is why it is listed below the line in this entity. Then we have the primary key foreign key relationships clearly defined. So the key attributes that are mentioned here for each entity can also be used as a primary key, and these primary keys are referred as foreign keys in the sales entity table, as it is apparent from the word FK enclosed within parentheses. Right? So this is a detail that has been added, and this was not available in the conceptual data model. The other thing to notice is the user-friendly attribute names. Right? So these are very easily readable. Right? Again, any technical or a non-technical person can easily understand what each of these entities means. And to help in the readability, we have also given a single character space between each word, right? And these words are by the dictionary. So it makes it very easy for anyone to read and understand, and doesn't take too much time to understand what each column means, because they are self-explanatory. And given all these changes that we have done, or new things we have added to the logical model, it makes it more detailed than the conceptual model. And at this stage, this logical model is not dependent on any specific database, meaning you can take this logical model and you can implement it in any database. It may be Oracle, it may be SQL Server, it could be even a OLAP tool such as SQL Server Analysis Services, and so on. Right? So at this stage, it can be really converted to any database type. So that's the meaning of the word database agnostic, meaning it is not specific, rather it is generic. Now that you have added all these details, starting from the key attributes, non-key attributes, relationships, primary key, foreign key, and so on, given all this, it makes it a little more difficult to enhance if there are any change in comparison to a conceptual model, right? And this is usually implemented using a software tool such as Erwin or Power Designer. So these are tools that help you define a logical data model, which you can share, you can continuously update, and then you can convert it into a physical model as well. So we'll look at the physical data model in just a minute. So given all these additional properties of a logical data model, it makes it slightly more difficult than a conceptual model to update. Once you have finalized the logical data model, we go to the last step of a data model design, which is a physical data model. So a physical data model looks a little similar to a logical data model. However, there are some significant changes. Okay, so to begin with, here we don't refer to the entities as entities. Instead, we refer to them as tables. And what we used to call as attributes in the logical data model, now we refer to as columns. So you see, tables and columns are words specific to a database, whereas entities and attributes are specific to a design, a logical data model design. So when we create a physical data model, we should clearly be referring to these as tables and columns. The other thing that you notice is the column names. These column names are no longer user friendly. Instead, they are database compatible names. So if you have worked on a database, you know that as a rule, you do not use a space when naming a table name or column name. Although you can use a space, it becomes very, very difficult when you're writing queries using those list of tables and columns, right? And hence you avoid using any special characters or any space between the words. And one other thing that we do is we try to keep the column length as minimal as possible. So as it's evident from here, for product, the short form is prod. So product description is now replaced here with prod underscore DESC, right? So these are database compatible. So this makes the life of a DBA a lot easier by using names that are fully compatible with the database, as well as any queries that we are going to write. So the same applies for the table name as well as the column name. And now we have introduced the concept of a data type, right? So these data types mention what is the type of data that's going to be stored in every column. So as you can see here, we have varchar, we have integer, we have float, date, and other data types. So these data types are specific to a database. In this example, this physical data model is created for SQL Server, which is the Microsoft SQL Server database. So these data types are specific to SQL Server. If you were creating a physical data model for a different database, such as Oracle or MySQL, these data types would be different. Hence, a physical data model is specific to a certain database. Now, this makes it difficult for users to understand. So if you're talking about non-technical users, they will have a hard time understanding what each of these tables mean, what these columns mean, and what are these data types for. Right? So usually it's not recommended to share the physical data model with the users. You only share the logical data model. Now, since this has more details than a logical data model, it makes it even more difficult in order to enhance in comparison to a logical model. So let's assume that you got a sign off on the logical data model and you go ahead and created a physical data model for a specific database. Now, if there are any changes, you first need to apply those changes in the logical data model and then to the physical data model. So that's one kind of change which will take time. The other change is, let's suppose the database itself changed. Now you're thinking of implementing this in Teradata instead of SQL Server, which means a lot of effort has to be involved in converting these data types to something specific to Teradata, right? So that is where we have tools like Erwin and Power Designer that will help you in automatically porting over the data or porting over the logical data model to a physical data model of a certain type. And when it comes to a physical data model, it will also include other objects that are not immediately visible on this diagram, such as indexes, constraints, triggers, and other DB objects such as stored procedures, functions, right? So these are the objects that are very much required in order to implement a physical data model. So to summarize, a data model is a simple diagram that shows the list of tables and the relationships. There are three stages in designing a data model. We start with conceptual, which is highly abstract. Then we move over to the logical data model, which has entities and attributes. And finally, we have a physical data model that has the tables and columns along with data types, as well as additional database objects. And a physical data model is specific to a database. That's all there is to the stages of a data model. I hope you found this video useful. Thank you.